So a body continues in its state of uniform motion in a straight line or and rotational spinning motion unless compelled by some external force to act otherwise. Okay, so let's do uh, some uh, mathematical explanation of what I have just said in the law. Let me underline it with red. Okay, we will not deal with the rotational part. We will just deal with the um, uniform straight line motion. But the rotational part can be considered at the same time. It won't make big difference. Okay, so let's suppose the body moves from point A to point B in this direction and takes time t and travels distance vt from A to B. Okay, so the v is the constant velocity. V is the constant velocity with which the body is uniform velocity with which the body is moving in straight line. When I say the body is moving in straight line, it means the body of mass m is not getting any information of gravitation from anywhere. It means it's going in matter free space or deep space where there is no interaction with any other matter present in the entire universe, or in other words, that the same body is just screened from the gravitational effects of other bodies near or far from it. So, so for the time being, we just consider that it's going in a straight line. Okay, let's define this motion from a reference point or a gravitating mass O. Okay, so from the center of that, this this is a gravitating mass, but it's the body is not being influenced by the gravitational effect of this mass. So I just draw this gravitational mass for the sake of clarity, so that the reader can understand that after developing differential equations, we will eventually consider the existence of a gravitational mass and connect it with inertia and inertial motion. And it's because inertia is the DNA of gravitation. So once we have developed inertial equations, then we will eventually uh, uh, get them to explain gravitation. Okay, so let this distance from this gravitating mass at O to the point A be represented with small r, and the other distance that is variable within that time range be represented by r prime. And let this angle be phi and this angle be theta. Now phi is constant, but theta is changing with respect to time. Okay, so now we will use Muhammad Ghiyasuddin Jamshed Al-Kashi's theorem, the law of cosines, on triangle OAB. So, considering this angle first, the angle OAB, uh, we will write the Al-Kashi's theorem as, keep in mind that we are trying to establish Tahir angle, the existence of Tahir angle, and its importance as well at the same time in understanding Islamic physics. Okay, so Al-Kashi's theorem as below on triangle OAB. Okay, so r prime square is equal to r square plus v square t square minus 2r v t cos phi. Okay, so we have Al-Kashi's theorem. Okay, so now we will differentiate both sides of the above equation minus 2RV cos phi. Okay, so now we will bring the point B back to point A by putting the limits, because we are trying to establish a principle of instantaneity. We are trying to find the rates of change of one variable with respect to time instantaneously at an infinitesimally small instant. So we will put the limits. When t time tends to 0, b falls on A. When t tends to 0, r prime tends to r prime falls on r. Okay, so we get r dr over dt from the above equation is equal to v square 0 minus r v cos phi, which is equal to minus r v cos phi. So we cancel r on both sides, get dr over dt is equal to minus v cos. Here we will introduce an angle. Phi is equal to pi by 2 plus beta, where beta is equal to Tahir angle. As I said earlier in the beginning of the video, that Tahir angle is of fundamental importance in the understanding of Islamic physics. Okay, so when we uh, insert this identity, we get dr over dt is equal to v sine beta. Okay, so we have established one part of the establishment of angle, Tahir angle. Now we will go to the next part. In order to get the next part, the next result, we need to prove an intermediate identity that is necessary for the derivation of the other part. Okay, so for the derivation of that intermediate identity, we will consider the same equation before putting the limits as gone above. So I will write the same equation here. 2r prime dr over dt is equal to 2v square t minus 2rv cos phi. Okay, so this is the equation that we differentiated before. So now we will differentiate it the second time. Differentiating the above equation with respect to t again, we obtain so this is 0 because r constant, v constant, and phi, angle phi is phi or phi, whatever it is constant as well. Okay, so we have got this equation here. This is v square. Okay, so putting the value So we get dr over dt plus r after taking the limits, d square r over dt square is equal to v square. So we'll put the value of dr over dt. So it will become v square sine square beta plus r d square r over dt square is equal to v square. So d square r over dt square is equal to v square minus v square sine square beta, which is equal to v square cos square beta r. So d square r over dt square is equal to v square cos square beta over r. So this is the intermediate identity that we need to put in the next equation to get the second result along with dr over dt is equal to v sine beta. Okay, so this is, let us call this equation 1 and call this equation